Hi everyone, my name is Ravi Prakash and welcome to the session of base system. So it's a part of number system only, right? And we'll deal with different bases here. So we'll try to unleash this base system here. Okay. So all the concepts of number system will be same. Okay. Just we need to understand that we have to work in different bases, which we are not comfortable with, right? Because from starting only, from our school days or in our graduation or in plus 2, right? What mathematics we are doing is in base 10 system, that is decimal system of mathematics, right? And now we have to come to different kinds of bases, right? Other than base 10, we'll say base 9, base 8, base 16, base 20 also, could be base 100 also, right? So all these things we'll see. All those very beautiful concepts we'll cover. So we'll try to start from very basic and move to the highest level of base system that is required in examinations like CAT and ZAT. Okay. So let's start base system. Okay. So we'll see here, like for example, if we have a base 10, right? So if we have a base 10, so all the digits I can use is from 0 to 9, right? So this is true for any base, right? So all the if digits I can use in any base is one value less than that base, right? For example, if I have base 5, so digits I can use here is from 0 to 4. I'll tell you the reason, right? Why is it so? Why we take digits 0 to 4? It's a part of remainders, right? I'll tell you in this video later on. Okay. So right now understand that whatever base you are using, digits I am allowed to use is from 0 to that n minus 1, right? So for any base, let's say base is 8, digits I can use is from 0 to 7, right? For example, if I have something written like this, 268 in base 7, right? So basically this number doesn't exist in mathematics, right? This kind of number field doesn't exist in mathematics, right? Because 268, if it is base 7, if base is 7 here, then maximum digit I can use is 6, right? So let's say if I write a number like 521 in base 5. Again, this kind of number doesn't exist in mathematics, right? Because mathematically it is wrong, no? Right? If I'm using base as 5, so digit I can use maximum is what? It is 4. I can't use a 5 here, right? So all these digits should be less than the value, right? Like 268 in base 9 is the correct number. Because if base is 9, maximum digit I can use is 8, right? So I can say that, I can generalize it, in any base n, okay, in any base n, digits I can use is from 0 to n minus 1, right? Okay, it's clear, right? Now let's say, so just right, we have to be comfortable with this kind of numbers, okay, working in different base systems. So just understand that, let's say, if I work in base 7, so how does the things go like? The single digit number starts from 0, 1, 2, 3 till 6, right? Then like 0, 1, 2, 3 till 6, okay. It's like 0, 1, 2 till last is 6. Then 7, 8, 9, 10 won't at all come. As in our base 10 system, right? Then it goes to 11, 12, 13 like that, and last number will be 16. Correct. 17 won't come in base 7 because base digit I can't use is more than 7, right? Then similarly 21 till 26, fine, all fine, right? And the maximum, the last two digits 61, 62 till 66. As in base 10 system, the maximum two-digit number is 99 because in base 10, the maximum digit I can use is 9. So in base 7, the maximum digit I can use is 6. So maximum two-digit number will be 2 digit number will be 66, right? This is the end here. Then 2 digit number ends at 66, right? In base 7 there won't be any 67, 68, 69 like that, right? Then we move on to directly my first 3 digit number is what? It should be 100, right? After 66 in base 7 there comes 100, right? Then 100, 101 like that till 106, and it goes on like this, right? So see, just we have to be comfortable, right? We have to just be comfortable in our mind that okay, in base 7 after 66 67 won't come, right? After 66 we jump to 100 because I can't use any digit more than 7 or more than 6 in base 7, and all the numbers after 66 till 100 in base 10 mathematics have got digit more than or equal to 7. That's why 67 to 100 won't come at all in base 7, right? So as this video will go on, right, we'll be comfortable with this kind of numbers. Okay, now let's move on. Okay, so first we'll see now how to convert any base 10 to base n, right? That's the most basic thing we should know. How to convert any base 10 to base n. Base 10 to base n. How do we convert it, right? So for this, there's a direct approach, right? Mathematical approach. Okay, I can say a direct shortcut also. But for the sake of mathematics, we should understand that what is the meaning of actually base. What does base in mathematics actually means, right? For example, let's say if I write a number here, 3645 is a number in normal base 10 mathematics, right? So what does it mean? What does it mean in base 10 mathematics? How do you represent here, right? So base in any system in mathematics, it means that if I'm writing in that base, for example, base 10 here, what is the highest power of that base that divides the number, right? For example, so if 10 is the base here, so what is the highest power of the base that divides the number, right? So let's say number is 10 cube. So because 10 cube is the highest power of the base that will divide this number. Obviously 10 cube is 1000. 1000 will divide it 3 times, right? So out of 3645, 10 cube into 3, 3000 we have used. So now we are left with 645, right? Now the next highest power of 10 that divides 645 is 10 square, obviously. So 10 square will divide 645 6 times, right? So out of 645, 10 square into 6, that is 600 we have used. So now we are left with what? 45. Now the next highest power of 10 that divides 45 is obviously 10 raised to 1. So 10 raised to 1 will divide 45 4 times. So again, out of 45 we have used 40, so only 5 is left. Okay, and so last we write simply 5, or just for the sake of the order, 3, 2, 1. So we write 10 raised to 0. Right. This is the meaning of base. So we start from these places, right? The single digit number is 5. Then at 10's place it is 4. Then 6. Then 3. So my number is basically 5, 4, 6 and 3 in base 10. Right. This is the basic funda of writing in any base. And this concept I can take on to any base, right? Any base. So let's say if I want to convert a number like 1163, okay, it is in base 10 right now. I want it to convert to base 8. So how do we convert it? Right, the similar procedure we will follow, right? If I wanted to convert this number in base 10, what I should do actually? Divide by the highest power of that base, right? If I want to convert this number in base 8, I should divide by the highest power of 8, right? So what is the highest power of 8 that will divide this 1163? So obviously 8 cube is 512. So obviously, right, let me write here. So 8 cube is basically 512. So obviously 8 raised to 4 will be more than 4000, right? It is 4096. So highest power of 8 that divides this number is 8 cube. 8 cube is 512. 512 will divide this number how many times? 2 times. So out of 1163, we have used how much? 8 cube into 2, that is 51 into 2, that is 512 into 2, that is 1024. So we are left with 139. We are left with 139. Then the next highest power of 8 that divides 139 is again 8 square. Right, it should be 8 square now. So 8 square will again divide it 2 times. So 8 square will again divide it 2 times. So out of 139, 64 into 2, 128 we have used. Right, so just left with 11. So next highest power of 8 that divides 11 is obviously 8 raised to 1. So 8 raised to 1 will divide 11 one time. So out of 11 we have used again 8. So we are left with 3 now. So lastly only 3 is left. So we can simply write 3, or just to maintain this order we can write 3, 2, 1, or next will be 0. So 8 raised to 0 into 3. So what is the number now? So start from this last place, 3, then 1, then 2, then 2. So my number is basically, right, what is my number here? Okay, so my number is basically 3, 1, 2, 2 in base 8. Right, this clear? Right, this is how we'll write it in any base. Right, if I have to convert in any base, I can do like that. I can convert in base 5, base 6, base 7. It's all my wish, right? This side. Let's do one more example, and then we'll see the shortcuts to do it, right? So take up one more example here. For example, if let's say 719 is in base 10 and I want to convert this in base 6, right? So what is funda? Again we'll look that again, what is the highest power of 6 that divides 719? So obviously 6 cube is 216, 6 raised to 4 will be 1296. So maximum power of 6 is 6 cube, that will divide 719. Okay, so 6 cube will divide how many times? 3 times obviously, right? So let me write here now. 719 is the number. 6 cube will divide it 3 times. Okay, so 6 cube is 216 into 3, 648. Out of 719 we have used 648, so we're just left with 71. The next highest power of 6 that divides this 71 is 6 square. 6 square will divide it one time. 6 square divides it one time. So out of the 71, we have used 6 square into 136. I'm just left with 35 now, right? Then the next highest power of 6 that divides 35 is how much? Obviously 6 raised to 1. We'll divide it 5 times. Okay, so out of 35 we have used 6 into 5, 30. So I'm just left with 5. So we'll write simply 6 raised to 0 into 5. So now we have like 5, 5, 1 and 3. Correct. So my number is basically in base 6, 5, 5, 1 and 3. So 719 in base 10 is 3155 in base 6. Right. So now just get this funda, right? This will actually tell you that reason why in any base we can't use a digit more than or equal to that base, right? Like if base is 6 here, I told you, right? I told you that if base is 6, then digits I am allowed to use is only 0 to 5. Why so? Because this is the reason, right? What's the reason here? Reason is we obtain a number in a certain base by dividing by the highest powers of that base, right? So whenever I divide by that highest powers of that base, right, base. Okay, so if I'm converting in base 6 here, so if I'm dividing by this 6 always, right, 6 cube, 6 square, 6 1, so at last remainder, that remainder will always be what? Less than equal to less than 6. If I'm dividing by 6, then my remainder is always less than 6, right? My remainder can never be more than 6. Correct. So my remainder can never be more than 6. Okay, I hope it is clear, right? So my remainder can never be more than 6. So all the digits I can use from only 0 to 5. So same way, if I have to convert in base 8, I have to always divide by the powers of 8. So remainder I will always get is what? Less than 8, right? Because remainder is always less than divisor. Fine. That's why digits, if base is n, so digits I can use only from 0 to n minus 1. This is the reason, right? Okay, now let's say a shortcut for it, right? What is shortcut for it? How can I directly convert this base 10 to base 6? So if I want to convert this base 10 to base 6, if you observe basically, so what we are doing is basically I'm dividing by 6 cube, then 6 square, then 6 raised to 0, right? So I'm just dividing by successive powers of 6. Successive powers of 6. Correct. So if I look at this directly, so how to convert 719 base 10 to base 6? So we'll simply write, if I have to convert 719 in base 10 to base 6, how should we do? Directly, we'll just divide by successive powers of 6 here. So simply write this 6 here, right? And write 719. Okay. So 6 will divide 719 how many times basically? This is a funda, right? So if you observe 120 into 6 is 720, it goes 119 times, right? So 119 into 6 is basically 714. So I'm left with 5. Okay. Now, again we divide by 6. 6 will divide 119 19 times. 19 6 is 114. We are again left with 5. Now 6 will divide this 19 3 times, and then we are left with 1. So now it's like we won't be dividing it again by 6 because 3 is the least number. It won't be divided 6 now. So what we do now, we take up all the remainders here starting from this last, right? So it goes 6 3 ja 18 and 1 is the remainder. So start from this 3 and move in reverse order. So like 3 1 5 5. So my number is basically what? 3, then 1, then 5, then 5. So 3 1 5 5 in base 6 is my number. If you look at the last slide, I got the same number, right? That is 3155 in base 6. But obviously, this is much faster method, right? This is much faster method, but it's more of a mechanical method, right? We know we have to do every time this. So basically, that was that funda. You have to understand mathematics also, right? So why it is so? Once you understand mathematics, now I can move to this shortcut. Directly, I can move from any base n to from any base 10 to base n, right? I can simply solve like this. Okay. And again, the reason being is basically successive division means what? Now, if you combine it 6 into 6 into 6, so 216 will divide 719 basically 3 times. So 216 6 into 6 into 6 divides 719 3 times. So that's why we start from the last. I hope it is clear, right? So now let's do one more example. We also did converting 1163 in base 10 to base 8, right? Now let's do it by the shortcut method here. So what we'll do here, we'll put 1163 here and we'll divide it by 8. So now 8 will divide 1163 how many times, right? So if you observe a little bit, 150 into 8 is 1200 basically, right? So 145 into 8 will be 1160. So 145 into 8 will be 1160, right? You should do these mental calculations, right? It's always good to have this kind of mental calculations. Okay. So 145 into 8 is 1160 and now remainder is 3. Again 8 will divide 145 how many times? So again you can do mental calculation. 17 8 ja 136, 18 8 ja 144. It divides 18 times and 1 is the remainder, right? Then 8 will divide 18 2 times and then 2 is the remainder. That's it, right? So 2 2 1 3. Start from the last always. So 2 2 1 3. So my number is what? 2 2 1 3 in base 8. That should be the answer. I hope it is clear, right? So this is how you convert any base 10 to base n. Okay. The next thing we need to learn is how to convert any number from base n to base 10. Base n to base 10. So how do you convert any base n to base 10? So just take the last example, right? So what we saw in last example actually, the number was like 2213 we got in base 8. And so what is this number in base 10? I want to convert, right? So we know what is the number 1163. We just did it in the last example, right? So it's like just opening, it's like just when we want to convert to base 10, it's just like opening up this bracket, right? How do you open up this bracket? With the powers of 8. So it's simply like 8 raised to 0 into 3 plus 8 raised to 1 into 1 plus 8 square into 2 plus 8 cube into 2. Right. So if you solve it, you will see this is 1024 plus 128 plus 8 plus 3. Right. So it becomes 1152 plus 8 plus 3, 1163. That's what you saw in last example, right? So it's just like opening up the bracket. Why? Because we just converted this base 10 to base, we just converted reverse, right? You remember in last slide, 1163 was in base 10. We converted it to base 8, right? 2213 in base 8. Okay. By dividing by successive powers of 8. Okay. So now while converting from base 8 to base 10, we just return it back, right? So all the powers of 8, like 8 raised to 0 into first digit, then 8 raised to 1 into second digit, 8 raised to 2 into third digit, 8 raised to 3 into fourth digit, right? So we do like this. For every number we do like this, right? So for example, take like suppose we have A, B, C, D in base n. So in base 10, what it would be base in base 10, right? What this number is in base 10. So in base 10, what we'll do? We'll simply open up the bracket, right? It should be simply like, put one E also, okay? Simply like, then start like n raised to 0, then n raised to 1, then 2, then 3, then 4, right? So start like, it should be n raised to 4 into A plus n cube into B plus n square into C plus n raised to 1 into D plus n raised to 0 into E. That's it. That should be the answer, right? So we converted this base n to base 10. So see, this is the most important thing required here, right? Converting any base n to base 10. Okay, and converting any base 10 to base n. This we should know, right? In logical exams like CAT and ZAT, right? Or any good aptitude examination where this base system questions may come, right? It is the most, it will mostly based on numbers funda. What we have done in numbers, right? We have done more than 50 videos in numbers. I hope you have studied all those videos, right? If you studied all those videos, not a single question you can miss in your examinations like CAT and ZAT or any good examinations, aptitude examinations, right? So now in base system, all those concepts should be very helpful, and we'll be brushing up all those concepts in different bases now, right? It factorials will come, remainders will come, some new concepts will also come, right? So we'll see all this in the coming slides, okay? So first thing we should know is how to directly write any number in base 10, right? Any number in base 10 from maximum to minimum in that different base, right? So for example, what I'm saying is, let's say if I write what is maximum 3-digit number in base 5. So maximum 3-digit number in base 5 is what? It should be what? It should be 444, because in base 5 the maximum digit I can use is what? It should be 4. Okay, so maximum 3-digit number in base 5 should be 444, right? Okay, so what is the number in base 10 actually? So it is 444 in base 5. So if you want to convert in base 10, so what is 445 in base 10? So 445 in base 10 is simply open up the bracket. So like 5 square into 4 plus 5 raised to 1 into 4 plus 5 raised to 0 into 4. It becomes basically how much? 100 plus 20 plus 4, 124 in base 10. Right. Now just try to connect it, right? We don't need to do this much. We don't need to do this much, right? Answer is correct 124, but we can get it by direct observation, right? We don't need to always solve these many values, right? Because if you just observe in base 10, what happens in base 10, right? So see what happens in base 10. So in base 10, if I say in base 10, what is the maximum? What is the maximum 3-digit number? Right. So maximum 3-digit number in base 10 is how much? It should be 999. What is 999 here? That 999 is basically 10 cube minus 1. 10 cube minus 1. So in base 10, The maximum 3-digit number is what? 10 cube minus 1. 10 cube minus 1. Right. So, similarly, just connect with base 5. So, therefore, in base 5, the maximum 3-digit number should be equal to, in base 10, 10 cube minus 1. So, in base 5, simply 5 cube minus 1. That is equal to 124. 124, right? So see, base 5 maximum 3 number. Now this is converted to base 10 actually, right? This is no longer in base 5. So I'm talking about base 10. So in base 5, what is the maximum 3 number? That I know. It should be 444. It should be 444, right? But when converted to base 10, what is the result? 5 cube minus 1, 124. Directly we can do, right? No need of calculating like this, 444 in base 5, and then you open up the bracket to solve in base 10, right? Directly we can do, right? Take one more example. What is the maximum 4-digit number in base, let's say 8? So maximum 4-digit number in base 8 is actually, right? So we should connect with base 10 now. The maximum 4-digit number in base 10 is how much? So maximum 4-digit number, right? Maximum 4-digit number in base 10. Just think like this. Maximum 4-digit number in base 10 is how much? It is 9999. That is 10 raised to 4 minus 1. 10 raised to 4 minus 1. So obviously, maximum 4 number in base 8, simply replace 10 by 8, right? It should be 8 raised to 4 minus 1. That is how much? What is 8 raised to 4? So 8 cube is 512. 512 into 8 is 4096 minus 1, 4095. And this is right. This is in base 10, right? This is in base 10, not in base 8, right? This is in base 10. So maximum 4 number in base 8 is how much? 8 raised to 4 minus 1, that is 4095. Simple, directly we can do, right? We know what is the maximum 4 number in base 10. It should be like this. So maximum 4 number in base 8 should be 7777 in base 8. And when we convert to base 10, it will come as 4095, right? So why to do this much calculations, this kind of calculation, right? Not needed. Directly we can apply it. So if you want to say it directly, let's say what is the maximum 3 number in base 7? 7 cube minus 1. Simply because maximum 3 number in base 10 is 10 cube minus 1. So maximum 3 number in base 7 is 7 cube minus 1. Okay. What is the maximum 4 number in base 4? So maximum 4 number in base 10 is 10 raised to 4 minus 1. So maximum 4 number in base 4 is 4 raised to 4 minus 1. Right. This is how it goes. Right. Now let's do a question. Let's do a question on this. It will open up your hands in this base system basically, right? So a good practice in this question, understand the logic behind it, and then you can easily connect base system from there, right? So the question is basically a good question to start with, a conceptual question, but at the same time we can understand the inner meaning also. So basically first question is, how many 3 numbers in base 10 are there which are 3-digit numbers in base 7 as well as 3-digit numbers Okay, this is a question here, right? So question is, how many 3-digit numbers in base 10 are there which are 3-digit numbers in base 7 as well as 3-digit numbers in base 6 as well as 4-digit numbers in base 5, right? Now let's try to understand this concept here. A very good concept. So if I'm talking about 3-digit numbers in base 7, 3-digit numbers in base 7, right? So I don't know how many numbers will lie, right? Because my range is 3 numbers in base 10. So 3-digit number in base 10 is from 100 to 999, right? So to look out for all those numbers in between, which converted to base 7 will remain a 3-digit number, right? So directly I can't think. So let's say what is the range for base 7, right? What is the range of 3-digit numbers for base 7? So what is the maximum 3-digit numbers in base 7? So maximum 3-digit number, number actually should be. What is the maximum 3-digit number in base 7, right? So this is, I can do like this, right? Understand, I can do like this, 666 in base 7. But there is no need to do like that, right? I can directly write maximum 3-digit number in base 10 is 10 cube minus 1. So maximum 3-digit number in base 7 is 7 cube minus 1. That is equal to 342. And this is in base 10, right? We have discussed in last slide. This what answer comes here, it is in base 10, not in base 7, right? In base 7 it is 666. In base 10 it is 342. Okay. What is the minimum 3-digit number in base 7? So minimum 3-digit number in base 7, it is equal to what? It should be 100 only, right? So 100 in base 7, it should be 100 in base 10. Because in base 7, the minimum 3-digit number, I'm really sorry, wait. It should be 100 in base 7, right? But again, do we need to solve like this and convert to base 10? No, I can do it directly. How I can do it directly? Minimum 3-digit number in base 10 is 10 square. So minimum 3-digit number in base 7 is 7 square. That's it. It should be 49 in base 10. Right. So 49 in base 10 is basically 100 in base 7. Okay. But we don't need to solve like that, right? First write 100 in base 7 and then convert to base 10. It will be 49 only, right? You can do it and check it. But directly do it, right? I told you directly do it. Just connect with base 10. In base 10, the maximum 3-digit number is 10 cube minus 1. So in base 7, 7 cube minus 1, 342. In base 10, minimum 3-digit number is 49. Is 10 square. So in base 7, the minimum 3-digit number is 7 square, right? That is 49. Okay, then I can move forward here. Right, let's say I talk about this base 6 as well. Okay, so maximum 3-digit number in base 6 is how much? So again, in base 10, 10 cube minus 1. So in base 6, 6 cube minus 1. That is equal to 215. And this comes in base 10. This answer comes in base 10. Because what is the answer in base 6? 555. Maximum 3-digit number 555. In base 10 it is 215. Then minimum 3-digit number in base 6 is how much? It should be 100 in base 6. So I can do directly. In base 10, 10 is square. So in base 6, 6 is square. So 6 is square is basically 36 in base 10. Correct. In base 6 it is 100. 100 in base 6 is 36 in base 10. Right. And then we can concentrate on base 4-digit numbers as well, right? In base 5. So, just I'm rubbing out this question here, right? So I hope you have written this question, right? Maximum 4-digit number in base 5. So in base 10, it is 10 raised to 4 minus 1. In base 5, it is 5 raised to 4 minus 1. When converted to base 10. When converted to base 10, right? This is what? This is 624 in base 10. Okay. And then what is the minimum 4-digit number in base 5? So in base 10 it is 10 cube. In base 5 it is 5 cube. That is equal to 125 in base 10. Right. So what was my question here? My question was, how many three-digit numbers in base 10 are there? How many three-digit numbers in base 10 are there? Right. Which are three-digit numbers in base 6, as well as three-digit numbers in base 5. Sorry, four-digit numbers in base 5, as well as three-digit numbers in base 7. Right. So I'll make a line diagram kind of, because in base 10, three-digit numbers are from 100 to 999. Okay, 100 to 999 is the range of three-digit numbers in base 10. Now, in that, range of maximum to minimum three-digit numbers in base 7 when converted to base 10 is 49 to 342. But I'm not concerned with 49 because I'm just concerned with three-digit base 10 numbers, right? That starts from 100. So 49 to 342, I'm concerned with 100 to 342, right? Before 100, I'm not concerned with. So 100 to 342. Let's say somewhere here 342 will lie, right? This is my first line. Okay. My second line, maximum to minimum range for three-digit numbers in base 6. Okay, when converted to base 10, it is 36 to 215. Again, before 100, I'm not at all entertaining, right? Because I only know I only require what? Three-digit numbers in base 10. Okay, so 36 to 215 means 100 to 215. So 100 to 215. So let's say somewhere 215 will lie here. This is my second line. Okay. Now third line is maximum to minimum in base 5. That is 125 to 624. So that's fine. 125 to 624. Okay. So somewhere here 125 will lie. Let's say 125 to 624. Somewhere here 624 will lie. So what I'm looking for, condition satisfying all these four conditions simultaneously. These three conditions and fourth condition being it should be three-digit numbers in base 10, right? So what is the area where all the four lines are there? So all the four lines are there in this area. All the four lines are present in this area, right? See, 215 to 125. So 215 to 125, all the four lines are present, right? That means this is the intersection of all these four. So what is my answer? My answer is 120. My answer is 125 to 215. How many numbers? Difference of 90 plus 1. That is total 91 such numbers are there. Total 91 such numbers, right? This should be my answer. Correct. So that basically means what? If I pick any number from 125 to 215 and if I pick any number from 125 to 215 in base 10, if I convert to base 7, it will be a three-digit number. If I convert it to base 6, it will be a three-digit number. And if I convert it to base 5, it will be a four-digit number. So all the numbers from 125 to 215 in base 10 will satisfy these four conditions simultaneously. This is the answer, right? So okay, we'll continue this base system in the next session. Thank you for watching.